In this video, we will see how to design active clipper circuits using op-amps. A clipper is an electronic circuit that removes the part of the input above or below a reference voltage. They can be classified into two types, namely, positive clippers and negative clippers. Let's see the negative clipper first. The negative clipper removes the part of the input below a reference voltage Vref. That is, the output voltage follows the input voltage as long as Vn is greater than Vref. Once Vn drops below Vref, the circuit removes this part and saturates at Vref, as long as Vn is less than Vref. Once Vn rises above Vref, the output again starts following Vn. Now if we set Vref as 0 volts, the waveform resembles that of a positive half-wave rectifier. That is, the half-wave rectifier circuit can be converted to a negative clipper by just controlling the clipping voltage Vref. This can be easily done by connecting a voltage source to the load resistor. The circuit still acts like the half-wave rectifier. But now, the diode becomes forward biased and starts conducting when Vn is greater than Vref. When Vn is less than Vref, the diode becomes reverse biased and Vout is latched to Vref. The transfer characteristics of a negative clipper looks like this. If we change the value of the voltage source Vref, then the circuit clips the input signal at the respective voltage level. Note that this is a precision negative clipper just like the precision half-wave rectifier. The op-amp ensures that the circuit clips the input at the level Vref with great precision. Similarly, if we look at the positive clipper, then the circuit removes the part of the input which is above a reference voltage Vref. That is, the output voltage follows the input voltage as long as Vn is less than Vref. Once Vn exceeds Vref, the circuit removes this part and saturates at Vref, as long as Vn is greater than Vref. Once Vn drops below Vref, the output again starts following Vn. Just as we did with the negative clipper, the positive clipper circuit can be easily constructed by connecting a voltage source to the load resistor of a negative half-wave rectifier circuit. In this case, when Vn is less than Vref, the diode becomes forward biased and conducts. Hence, Vout is equal to Vn. When Vn is greater than Vref, the diode becomes reverse biased and stops conducting. Hence, Vout is latched to Vref. The transfer characteristics of a positive clipper looks like this. The clipping level can be changed by changing the reference voltage source value. That's all for this video. If you have any doubts, feel free to ask in the comments section below. Don't forget to like, share and subscribe.